So welcome back. We have William DiPoala today with his UAP Detector presentation. Bill, with a 38-year career at Robert Bosch GmbH, William DiPoala specialized in the design, development, and manufacturing of advanced motion detectors for security systems. Bosch, a global leader with over 130 years in the business, employs more than 300,000 people worldwide and generates approximately 100 billion euros in revenue. Throughout his tenure, William earned a place as one of Bosch's top 18 inventors in company history. He contributed to over 40 patented technologies, with 3 patents currently pending for the UAP detector. During his career, William developed motion detectors incorporating various advanced sensor types, including thermal infrared, the 10 gigahertz Doppler radar, the magnetic Hall effect, the 3-axis accelerometers, 900 nanometers active infrared, and ultra-wideband radar. Following his retirement from Bosch in 2021, William immediately dedicated himself to the development of the UAP detector. And before we get started, Bill, what is an active infrared? I know what passive infrared is, but what's active infrared?
Yeah, so active infrared uses infrared light source like your remote control for your TV.
Oh,
So
okay.
it illuminates an area, and then there's an infrared sensor that would some reflection from that light source.
Gotcha. Okay, and with that, thank you, Bill. The floor is yours, sir.
Okay, thank you, Jared. Yeah, so I spent the first 38 years of my career working on sensors to detect humans. Then I retired, and now I'm working on sensors to detect non-humans. So this is actually more fun for me. So I'm enjoying this right now. So I thought I'd first go over a quick agenda, what I'm going to talk about today. There'll be a quick overview of the ET302W UAP detector. I made a short marketing video. It's the first time I made a video, so the quality may be not so good, but it explains what the detector does. Then I'll talk about my first UAP encounter that kind of triggered this device development. Talk about the motivation for creating the device. Then I'll have some videos to share with you that demonstrate the device in action. I didn't think I could pull off a live demonstration, so I made these short videos just for this presentation. Then I'll go over the specifications. Then if there's time and interest, I can talk a little bit about a trip I went with my brother, visited the Skinwalker Ranch area in May, and we have some videos that my brother and I made to kind of discuss what we saw when we were there. It was interesting. And then I talk a little bit about maybe what are my next steps for this UAP development project. And I'll have to open it up for questions. We can ask questions along the way too, no problem. Particularly in between some of the videos, I'll stop and pause, see if there are any questions from the group. Okay. So this UAP detector is designed to monitor your nearby environment, typically your house. So you place this device near a window. It works 24/7. If it sees a change in the environment based on the 3 sensors that it has, the LED will flash and the sounder will beep a few times to grab your attention. The idea is then that you would grab your camera or other equipment, head outside, and look to see what might be going on. Hopefully it's a UAP flying above your house. The device also works with a phone. So there's a phone app that you can access the sensor data, event time, and stamp and information's all within the app. We'll give you a demonstration of that later. Internal to the detector, there's 3 sensing technologies. There's a 3-axis magnetic field sensor, a 3-axis gravitational field sensor, and a 1.6 gigahertz RF or EM field sensor. It'll operate about 4 years on 3 AAA batteries. I'm sorry, 4 months. Wish it was 4 years. Tried real hard to get the life out a little more than 4 months. But the Wi-Fi module itself consumes a fair amount of current. So if you don't use the phone app and the Wi-Fi, the battery life goes out to about 2 years. So 4 months with Wi-Fi, 2 years with no Wi-Fi. It's real small, portable. You put it in your backpack, take it out with your field test or whatever. So it's a handy little toy. Here's the video, this marketing video I made. It's not very long, but it'll give you an idea what the detector's all about.
Step into the unknown and embrace the adventure of unraveling the mysteries of the universe with our groundbreaking UFO UAP detector. Designed for those with a keen interest in exploring the enigmatic UFO UAP phenomena, this device integrates the most advanced MEMS-based sensors, placing a potent pocket-sized research tool in the hands of everyday explorers. UAP vehicles are theorized to utilize gravitational propulsion systems. Thanks to our state-of-the-art detector, you won't miss the next sighting. Equipped with a highly precise 3-axis gravitational field sensor, our device identifies minuscule changes, as small as 5 milli-G, in any direction, giving you the chance to monitor unusual gravitational activities that may signal UAP presence. Furthermore, many airline pilots have reported their magnetic compass spinning during UAP encounters. You too can follow the compass. Our detector features a 3-axis magnetic field sensor, sensitive enough to detect a change of 5 milligauss, roughly equal to a 5-degree position change of a magnetic compass. Confirmed by the U.S. government itself, electromagnetic radiation often escalates during a UAP event. Stay on top of these occurrences with our detector's high-sensitivity 1.6 GHz EM field sensor, designed specifically to monitor the frequency most commonly associated with UAP events. Once a UAP event is detected, our device alerts you with a multicolored LED and beeping sound, urging you to take swift action for additional observations and measurements. If you're away from the device, don't worry. You can receive instant notifications on your mobile phone via our free app. While the government has been studying this phenomenon for decades, a wall of silence has been erected in the name of national security. We believe in the power of public research. It is time to put the truth back in the hands of the people. You are part of that journey. Only through your curiosity, study, and sharing can we collectively unveil the true nature of UAPs. Be the trailblazer of discovery. Unlock the secrets that the universe holds. Disclosure lies within your grasp. Don't just believe, observe, explore, discover.
Okay, so as I said, it was not the highest quality video, but gives you an idea of what the detector's all about. So now I'll talk about my close encounter. In 2009, my wife and I were driving home from my niece's birthday party out near Buffalo. And on the way home, we came around the corner and we see this diamond-shaped object about 40 feet above the ground. We both looked at each other and were kind of puzzled. And my wife says, "Well, that's not a kite." And then I said, "Well, it's not a plane." And then she said, "It's this or that." We went back and forth as we were driving under this thing, but we couldn't identify what it was. It was perfectly silent. It didn't move at all, perfectly stationary. What stood out the most to me was how still it was. Even there weren't drones back in those days, but even now when you watch a drone, it's relatively stable, but it moves around a little. This was perfectly still, really odd looking. As we drove under it, I slowed down to about 5 miles an hour. It was close enough I could have thrown a rock at the thing, but I didn't stop because there was traffic in back of us. So I went around the corner. It was maybe only about 100 yards, and I pulled into a driveway, and I said to my wife, "We have to go check this thing out. I don't know what that was." So we drive back. Couldn't have been maybe a minute after the initial sighting, and got out of the car, looked around. It was gone. There was nothing there. We stood out there kind of baffled for a minute or so just talking about what we just saw, but didn't see it again. It was gone. It was very strange. I've never seen anything like it till then, and still haven't really seen anything that bizarre in my life. So that's the story. It was in the middle of the day. No sound, no propellers, nothing, no lights on it. It was just very strange. So ever since that day, I can't stop thinking about this. Wish I had a camera. Wish I had actually pulled over initially and watched it, but I didn't. We kind of drove underneath it. So it's quite an experience for both my wife and I. Anyone have any questions about the sighting before I move on?
Yeah. So, the sides, you said it was faceted. You said all the sides were they perfectly flat? Was there any rounded edges on that thing at all?
No rounded edges. It was faceted in sections. I tried to recreate it in the photo there.
Yeah.
There was actually more facets than you're seeing there. It was maybe I could see 4 on top and 4 on the bottom, but overall it was diamond shaped. Real smooth, no lights, no windows. People say, and I didn't see any rivets or any details other than this shape. It was just a really clean looking shape.
Hmm. And was it off to the side of the road? Were you ever absolutely underneath it, or?
I drove directly underneath it.
Huh.
And so, I'm looking at, through the windshield as we're driving under it with, my mouth open, going, I don't believe what I'm seeing, because it was just so strange.
Huh. All right. Thank you.
Yeah. Any other questions?
Yep.
Okay.
Ivor's got a question. Can you unmute yourself, Ivor?
So, as you drove under, well, 2 questions actually. The first question is from the perspective of, I see the windshield wiper in the bottom of the frame. From that perspective, if I were sitting in that car, would that be about the size of the item or of the thing relatively in your recreation?
Yes. I
Okay.
tried to get the size about right. So it's
Okay.
about 8 foot wide and 4 foot tall. I thought, afterwards, it looked too small for someone to be in, person to be in it. I think physically they could couch up and be in it, but it would be so uncomfortable. It wouldn't be something that you would want to be in. So it was pretty small. It wasn't really big.
And as you drove under it and you looked up, were the facets of the craft or the item, were the facets similar from below as from what you could see from the side? Or was it differently faceted underneath?
It looks symmetrically faceted on top and on the bottom.
Okay,
Yeah.
so if I were to turn that item, 90 degrees up, it would look the same from the bottom as it. I'm confusing myself. The faceting would look the same from the bottom as it looks from the side, or were there more facets, or was it? Was there a difference in the symmetry and the size of the facets below, given the geometry we see from the side?
I'd say no, it was very symmetrical.
Very symmetrical. Interesting. Thank you very
Yeah.
much.
Sure.
Anybody else?
Jared, I have a question.
Yeah, go ahead, Tor.
Is there any possibility that it was interacting with those power lines at all?
Yeah, it could have been. I didn't see any arcing or hear any crackling noises. It could have been. There's some, it's not shown in this photo, but to the right of this image, there's some high tension power lines, I'll say a couple 100 yards away. Those big, with the big towers. It's very close to that area.
From this photo, it looks like it's sitting right above those power lines. Was
Yes.
that the actual case?
I think it was a little further than what you're seeing. Wasn't directly above the wires. Meaning I passed under the wires and then I passed underneath the object. But it was, close, maybe, 20 feet, 30 feet or something. And it wasn't as high as the trees. So it wasn't higher than the trees. Yeah.
The object was below the trees?
Yes.
Wow. And is this picture here the exact spot that you saw it?
It is. So I went back there a few weeks ago just for this presentation and took some photos. I took a video too. Unfortunately, I didn't download it. I was going to show me driving around that corner and you could see where I turned around in the driveway, but it's right around this corner, about 100 yards where I turned around and drove back, parked right over here, and got out of the car and looked around and didn't see anything. It was gone. It went from perfectly still to gone in less than a minute.
Wow. Okay. Anybody else?
I have two questions. This is Jamie. I was wondering if it created any sort of shadow that you noticed, or how the sky looked around the edges of the object as you looked up.
Yeah, I didn't see a shadow on the ground, but underneath it looked like it was darker than on top. It was casting a shadow on itself. And the day was overcast. I didn't recreate the weather, but it was an overcast day. But there's still enough light there. I could see that underneath it was darker.
Okay, thank you.
Did it distort the air around it at all? Could you tell?
I didn't see anything, like fuzzy. I got a real good look at it. It looked real crisp and sharp.
Okay.
But I didn't see any aura or anything around it. No light. It was charcoal black, It was, Yeah.
Anybody else?
This is Joe.
Yeah, go ahead, Joe.
I wanted to make sure that what we're seeing is your simulation here of the image from the side. Was it the same type of image underneath?
Yeah.
Okay. Thank you.
Okay. Barring that, go ahead, Bill.
Okay. So yeah, my motivation to make this detector was to have a device to improve the chances I could see another one. And I poured my experience into this design, made prototypes and got a system that looked like it was working, and shared with a couple friends, and of course they wanted one. And so then I couldn't resist the temptation of doing what I've done for 38 years and make a product out of it. So that's exactly what I did. I made a device that could be sold. What makes this device, different than what a lot of scientists are doing today is, sure you're all well aware of, they're making these very complex, accurate, expensive, complex systems to detect UAPs, which is needed. I think it's a great idea that people are actually making these systems. However, the cost and complexity ultimately limits the number of these systems they can launch into the field, hence reducing the possibility of detections. So this detector was designed to be low cost and very easy to use, with the potential of getting many more out into the field, into the public's hands, who then could make their own observations, collect better photographs, hopefully, with the sensor data that then could be shared and potentially pressure our lawmakers to disclose what they really know. I think that ultimately the pressure needs to come from the people. As I think you're all aware, they're not really wanting to share what they know. So there are approximately 100 detectors out in the field currently. About 20 of them I've given away to, I'll say, experts or professionals in the field. And I still welcome other professionals, if they're full-time investigators, to contact me and wanted to share devices at no cost. Right now, some of those detectors are in the field, and they are working. They're detecting at the same time. These expert equipments are also detecting events. So it's real encouraging to see that the system works, and hopefully we get more of them out in the field. Okay. I mentioned I have a few videos I'll share with you. I made them just for this presentation, so they're a little rough, but it'll give you an idea how the system operates. And I'll stop after each video and answer questions if anybody has.
We will demonstrate the operation of the UAP detector. On initial power-up or a reset, the detector will go through an initialization sequence. It performs an internal system test, testing each sensor and subsystem. The LED color indicates a passing test. Gravitational, magnetic, EM, battery voltage, Wi-Fi module. The detector will now establish sensor baseline values of the test location. Finally, it displays the sensor sensitivity level setting. The detector is now operational. A magnet is placed next to the detector to activate the magnetic sensor. Magnetic field detection is indicated by a green LED and sounder. The phone app indicates the event. The sensor current event signal data can be viewed on the chart screen. The historical event data is also logged on the chart at the bottom and can be viewed by day or month. The event history is logged in the app history screen. The detector will reset itself after 20 hours or can be manually reset by turning the device upside down until 2 beeps are heard. Place the detector back in the test location. The detector will cycle back through its initialization sequence and be ready to detect a new event. The detector's new baseline values will include the effects of the magnet in proximity of the detector. This concludes our UAP detector overview.
Okay, so any questions on that video?
Yeah, I got a real quick question for you. When it detects something and it goes off, how long does it go off? I mean, is like 30 seconds worth of beeps or 10 or until it's, set, or how's that work?
Yeah, so it's a good question. So to avoid the case where there might be something bothering it a lot and then the detector bothering you, I designed it so when one of the technologies is triggered, the sounder will beep 3 times, beep, 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 and the LED will flash. The sounder will not beep again after that, but the LED will continue to flash for 20 hours.
Okay.
If one of the other technologies activates, you will get the sounder to beep again 3 times, and then the LED will flash green and then red and green and red if they were those 2 technologies. Again, and it'll reset that 20 hours at that point. But then after 20 hours, it resets.
Thank you.
Sure.
Bill, how about weather? How does weather affect it?
So weather doesn't affect the sensor's performance at all, and neither does its location. Doesn't need to be outdoors. It's really designed as an indoor product. So if it's in a house with normal wood or block or stone construction, those sensors are not affected by that. If you were in a metal building, then of course the magnetic field sensor and the 1.6 gigahertz RF sensors would be affected. In that case, you'd want to get it near a window, and then those signals could be picked up through the window. The device is sealed with an IP54 type of rating. So it can be placed outside for short-term testing. It can get rain on it. It is sealed on the top. That LED is sealed internally, but it can't be submerged in water. So if it's sitting on a flat surface or a convex surface, if water was to collect and build up underneath it, the batteries would get wet, for example, and it would flood inside. But if it's on a flat surface where the rain can drain away from the detector, it's okay to be outside. I've got some units outside that have been running almost a year now, and the battery terminals are a little corroded, but they're still functional. But best to be inside so you can hear the sounder go off anyways. Okay.
What will it detect? I mean, as far as will it detect birds or planes, bugs, anything like that?
No, it will not. So, a bug doesn't produce magnetic fields or gravitational fields or this 1.6 gigahertz RF field. A plane also doesn't produce significant amount of magnetic fields or RF fields. And I actually have the last video I have for you about the last, but I have a video actually that demonstrates this detector sitting on top of a car and a plane flying, a few hundred feet above the car, and the detector won't go off. We'll show you that in a little while. Okay, this next video is going to show you some of the sensor signals that are internal to the device.
This is a demonstration of the UAP detector's internal sensor signals. The UAP detector is connected through a serial port to the laptop. The top graph is showing the 3-axis gravitational field sensor. The middle is the 3-axis magnetic field sensor. The bottom the 1.6 GHz EM sensor. A small magnet is rotated in proximity to the detector. The signals can be seen in the middle graph. A 1.6 GHz signal is transmitted and detected by the EM sensor. The signal is displayed on the lower graph. The detector is lifted and tilted to simulate a gravitational field change. The signals can be observed on the top graph. Note, a serial connection is not normally provided with the UAP detector.
Okay, so a note to make is, I think you may have noticed that when I was moving the detector around, the magnetic field sensor was also being activated or measuring signals. So it's actually showing you the relative position change due to the Earth's magnetic field. So as I'm rotating it, detecting that change like a compass would. And so both sensors were actually being activated when I moved the detector. Any questions about that setup?
Very interesting, I'll tell you that.
Off to the side here's
I got a real quick question for you.
sure.
What is the significance of the 1.6 gigahertz? I mean, you hear that often. The Secret of Skinwalker Ranch talks about it all the time. You're talking about it now. What is going on? What is the deal with that frequency?
I don't know what the deal is. It might have something to do with the propulsion systems generate RF fields. There's a lot of theories of this gravitational propulsion systems, and there's even some patents out on it, assuming it's the same, where they're using high gigahertz type RF energy to stimulate the field that causes the gravitational event. So I wish we knew. Can maybe share. There's a photo that I can share with you. You may have seen this before. That the government actually released this where they're showing this.
You got to talk to the microphone, boss.
Yep. So the government released this document where they're identifying this 1.3, 1 to 3 gigahertz RF signal that they detect in the presence of UAPs, and also an 8 to 12 gigahertz range. And I haven't been able to find anybody that has more detailed information on this 8 to 12 gigahertz range. So if anybody out there knows, I'm all ears, because the next generation detector that I'm working on, I'd like to include a specific frequency to measure and to monitor between 8 and 12 gigahertz. Right now I'm targeting 10 gigahertz, but it's just a guess. As I mentioned, the detectors in some other people's hands. Not sure I get in trouble mentioning this or not, with John Tedesco, if you're familiar with him, and his brother Terry. They have this Night Stalker RV that they are testing for UAPs in the Long Island area. Well, they have a couple of my ET302W detectors that they are currently testing along with their more elaborate system. And just this week, John contacted me and let me know that both of my detectors went off at the same time their equipment went off at 1.6 gigahertz, and they have the more detailed spectrum analyzer signals that they shared with me. It was right at 1.6 gigahertz. The detector went off and they had observed UAPs in the area. He didn't share the video or the optical data, but he said they had observations twice this week at 1.6 gigahertz. So yeah, I don't know what's with the 1.6. You know, Skinwalker.
Yeah.
They see it all the time. And mention, I'll share some information. I was in the Skinwalker area in May, and I also detected 1.6 gigahertz at the same time we saw an orb fly right by us. So yeah, I don't know what it is, but they're emitting it.
Interesting.
Any other questions?
Did you still want to do your raffle?
Yeah, absolutely.
Okay. All right. So just so everybody knows, Bill has volunteered to give away one of these today. If you are interested in receiving one, you can send a chat message directly to me, Minnesota MUFON, and just tell me your email address. And then Bill and I will hang out after the meeting and try to draw a name out of a hat to see who wins this. So if you're interested in receiving one of these, please send a direct chat to me, Minnesota MUFON, with your email address, and I'll make sure that you get notified if you win. Go ahead, Bill. Sorry to steal it.
Okay, no, thanks for bringing that up. Okay, so this next video is the conventional aircraft demo. So you can see here, I'll try to give you a little insight of what you're looking to see. So there's the UAP detector sitting on the hood of my car. I'm at my local airport. You can see right here's a plane about to come in for landing. I have a GoPro camera right in front of the detector here, and I have my cell phone. And I'm going to pan the cell phone towards the plane as it flies overhead. And you'll notice that the UAP detector doesn't activate on the airplane because the airplane doesn't emit 1.6 gigahertz. It's made out of aluminum, so it has a very small magnetic field associated with it. And of course, it's too small to generate a gravitational effect that my sensor could detect. In theory, there's a gravitational field that potentially could be measured underneath the plane, but I don't know what equipment could actually do that, but there probably is something out there. So I'll run the video for you. So yeah, the point is if the detector goes off and you head outside and see something in the sky, it's not an airplane. It's a UAP of some sort. This detector won't activate on a plane. What you heard in the background was someone's car alarm going off from the rumble from the jets. And I assume their battery will be dead when they come back because every plane that comes in, it was triggering their car alarm. Yeah. Any questions on this one?
So this is Jamie. I just heard you mention that aluminum has a small gravitational field. Have you ever heard of the possibility that some recovered crash sites contain pure aluminum? And I'm just curious if you have any knowledge on any comments on that.
Yeah, so I have heard of crash retrieval materials having pure aluminum and often layered with other materials in a way that we can't recreate. So you're probably aware of some of those reports. As far as it affecting gravity, so aluminum itself doesn't affect gravity in any other way than the mass of it. So aluminum being light actually affects gravity a little less. And gravity is proportional to the mass of the object. So a plane weighing a certain amount of weight is going to have an effect on gravity, just like the Earth does. But the Earth has so much more mass, we feel it. But you wouldn't feel a plane because the mass is not high enough for you to feel. That makes sense.
It does, yes. Does
Well,
aluminum have a unique electromagnetic field of any sort?
Not that I'm aware of it. Aluminum's a very good conductor, so it would shield electromagnetic radiation like RF fields a little more efficiently than some other materials, only because it's high conductivity. Copper and gold are other very good conductors. Aluminum's, as you know, is often used in wiring. The main line coming into most people's houses that heavy 20 amp service is often aluminum for cost. Copper is just too expensive. But in your house, probably copper wires.
Yeah. Just interesting to think about. That's all I had. It's just, it struck me as interesting. So that's
Yeah.
it.
Okay.
Bill, I assume that the field of range is circular here around the detector, but how far out will it go? What is the range of the detector?
Yes. So I get that question a lot, and it's not something I can define definitively because, for example, for the gravitational field, it would be proportional, the range would be proportional to how strong the field is generated by these craft. So I would assume a larger craft would have to generate a larger gravitational field to move it. And if it's accelerating quickly, I would expect it to generate, during that acceleration, higher amounts of gravitational fields. Same with the magnetic field. The larger the object, the more likely it's going to generate a larger magnetic field, even though that's theoretical. I think you're aware there's many pilots over the years have talked about their compasses spinning while they're observing these UAPs. Well, those pilots are often seeing crafts that are mile, 2 or 3 miles away, and their compass is still spinning. So I would expect this device to detect these UAPs a mile, 2, 3 miles away potentially. If the pilot is seeing their compass spin, their compass is spinning 360 degrees. This detector is sensitive enough to see only about a 5-degree change in a compass movement. So it's very sensitive. Matter of fact, if you have like a chair, like a folding chair, a metal chair, within about 5 feet of the detector, if you move that chair, it'll notice that magnetic field change because its effect on the magnetic field of the Earth, but also since it's metal, if it's steel in particular, it probably has its own small stray magnetic field charge on it, and it'll detect the chair moving. So it's important you put this detector in a very quiet location where people aren't moving objects or moving things nearby it.
Just to confirm again, it can be used and it's really designed for use indoors. So it actually, the sensors go through the roof and through the windows and it would detect in the sky then, huh?
Yes. Yeah, so the RF signals, the 1.6 gigahertz, is actually a little bit lower in frequency than Wi-Fi, right? Your Wi-Fi goes through walls. Your cell phones are typically around 900 megahertz, which is closer to that 1.6 gigahertz. And your cell phone signal goes through your walls, no problem, right? Maybe attenuated just a little bit. The magnetic field, right? You have a compass in your house. You can still tell north, south, east, west, right? Magnetic fields are not affected by building construction at all. If they were metal, if you were in a big metal enclosure, say like a warehouse with no windows, that would concern me. In that case, you would want to either put it near a window if there was one, or move it outside. Same with the RF signals, won't go through a metal wall. So if the building is solid metal with no openings, yeah, performance would be reduced greatly for those two technologies in particular. But most houses are made out of wood and concrete and block, no problem. These are the basic specifications of the device. It operates on 3 AAA batteries. As I mentioned, battery life about 4 months with Wi-Fi. Average current about 350 microamps. And the LEDs come on and the sounder or the RF transmitter from the Wi-Fi turns on. It might draw about 100 milliamps max. Magnetic field sensors, sensitive down to about 8 milligauss, 80 microteslas. That means anything to you. Gravitational field, 0.025 Gs. So the Earth produces 1 G, right, in the Z axis. If that 1 G changes even by 0.025 Gs, this detector will activate. And as I mentioned, there's a 3-axis sensor in there, so it'll detect a gravitational field change in all directions, even though the Earth's only acting in one plane. Same with that magnetic field sensor. There's primarily in one plane, but if any magnetic field change is detected, it will activate. So talk about the range of the RF detection at 1.6 gigahertz. So I've watched quite a few of the episodes of the Skinwalker Ranch, and I carefully, particularly in the older episodes, when I knew what system they had this SDR radio, which I purchased the same model so I could calibrate and understand how sensitive did my device need to be to detect those events that they're seeing in the Skinwalker area. And those signals were about 20 dB higher than my detector's capabilities. And 20 dB for you non-RF people is a factor of 100. So it's 100 times more sensitive than it needs to be to detect some of those events that the Skinwalker Ranch folks were seeing. So it's plenty sensitive enough is the point. Another comment on that 1.6 gigahertz is I also recommend to place the detector at least 10 feet away from any Wi-Fi device. So the Wi-Fi device is operated at 2.4 gigahertz, which is relatively close in frequency to the 1.6 gigahertz. So it can activate the device falsely if it's closer than about 10 feet from the detector. There is some filtering to reduce the effects of that Wi-Fi router or your phone or TV or anything that's running Wi-Fi. So if you keep it 10 feet away or more, you won't have a problem. If you're interested, I'll share some of the observations we had in Skinwalker Ranch. Regretfully, when we were there, we had observations, particularly one that we have a video recap of what we saw, but unfortunately, I didn't have any of my equipment, the high-end equipment, trained on this event when it happened. My brother and I were both sitting in chairs. It was cold out. This was at nighttime in the desert. And the only instructions I gave my brother was, if something happens, you have to spring into action, grab this camera, and record the event. My brother's a doctor. He's not a ufologist, but he was eager to see something, and he took the instructions fine. But when we had the event, we both sat there in awe of what we were seeing. And we went back and forth. I first saw it. I say, hey, Joe, my brother, Joe, do you see that over there? It was a light. And he goes, no. And then I pointed to the area where it was happening, and it came on again. He goes, no, now I see it. Yeah, you see that? What is that? And we went on and on while this event was happening, but we never got off our chairs. We were too taken in, and we were baffled as what we were seeing. So we didn't capture any high-tech event video or anything with it, unfortunately. But the UAP detector did go off. The 1.6 gigahertz sensor detected this event and triggered when this orb was about 300 feet from us. So I'll show you the video coming up of us recapping. I'll also share with you a video that shows all the prototype equipment that I brought with me on this trip. Some of the prototypes were sensors that I want to put into the next generation sensor. Some of the equipment was there just to help document and observe the events that we were hopefully going to see. And I'll play that video for you. Okay, it goes quick, so you have to read quickly. I could pause it, but I think you'll get the idea.
This is the future.
Sorry, let's turn it down a little bit.
Evolution. This is the future. Evolution.
So yeah, that was the equipment we brought with us. A point to make is there's this control box you see here that was actually able to modulate that 100-watt blue laser, the ultraviolet light source, and the infrared light source. I could encode a digital message into those light sources and project those into the environment, trying to stimulate some response and hopefully receive a response to the message, which I never got. But it was just a feature of that equipment that I made. Any questions on the equipment?
You're having this is Joe.
Hey, Joe.
You're having an infrared light source going out, and you're receiving infrared. Is that going to create problems?
Well, the infrared light source is a focused light source. So it has a mirror behind it and focusing mirror. So it's directing out away from us, just like
Yeah.
like the laser is heading out towards the mesa.
Your infrared source seeing it might see what if it hits something in the distance.
Yeah, it could. For example, that PTZ camera I have can see the same infrared wavelength. And if there was something reflecting off it, like a flying saucer, yeah, it would show up in the camera for sure.
Okay.
And it was pretty high powered. It was like 35 watts of light.
Yeah, you don't want to look at that.
Yeah, sure.
I do have some other possible suggestions, but I think I'll take it offline with you if you're okay with
Sure.
that.
I'm totally okay. Yeah, I know there's a lot of people with a lot more experience and expertise than I have. So if anyone wants to share insights into testing or methods or technologies, I'd love to hear from you. My contact information's available on the website, uapsensor.com, in the bottom of the shown in the bottom of the video. I'll write it down. But please, yeah, contact me. I'm always here to learn from people with a lot more experience than I have. Thanks.
The multi-level aluminum, magnesium, and bismuth metal layers.
Mm-hmm. Yep.
That's similar technology to what I worked with when I was in the service in '72. And we used it as a device to create electricity from a neutron stream.
Yeah, sir. So, one question is there a plan where these devices might be networked together via Wi-Fi so that, if there were a triggering event, we'd be able to track maybe, UAP or, events that, happen in sequential time? Anything like that going on?
There's nothing actively going on, but it's been discussed many times. I haven't made a database to collect this information. However, if you were to have, say, 10 sensors all on Wi-Fi networks, and they can be on different networks, you can remotely monitor all those detectors with your phone app. And the phone app collects the time and date stamp information of when an event happens. So it's physically possible to collect the data. It's also possible, for example, if you were to have one of these detectors, to share your data with me or any other user of this device. But you have to give them the access. So that's available through the app. You say, share my data with some other user. And they can actually see the same thing that you see on the phone app, all the sensor data, the status of everything in the history. So it would be relatively easy to have users just share their app data with some central location, but I'm not currently doing that.
Okay. Second question. Some years ago, I came across a research paper. It was by an Italian scientist, and he was doing radio frequency sensing technology. And this paper that was written specifically talked about sensing entities in the radio frequency spectrum that came out of this sensing system testing that they were doing. Have you ever come across that paper? I had it at one time. Of course, before I was able to get to read it, my hard drive failed and I lost it, and now I can't find it again. So I was just curious if you'd ever come across that paper.
No, I haven't. And I've spent hours looking at different databases trying to find very specific information on these RF frequencies and have not found anything other than this 1.6 gigahertz.
Okay.
It's often, it just says RF or a range, or some might say microwave frequencies or something. So no, I haven't seen it, but you say
if I come across it, I'll send it to you.
Oh, it'd be awesome. Thanks.
You bet.
I can move on to this orb that we saw that describes in more detail. It was more of a, what you're going to see is more of a recreation and an explanation of what we saw. Unfortunately, as I said, we didn't capture anything other than my detector activating. Oh, here we go.
And what's the other sighting had? Yeah, the other sighting was even more exciting, really. It was the second night we were there, and we saw what I've heard other UFO observers call an orb. It was a bright white light that was about 30 or 40 feet above the ground at tree level, and actually came along a kind of a line of trees. And as it came towards us, it would stay on for a few seconds and then go off, and then sort of reappear a little bit closer to us, and then go off, and then we saw a third time that it appeared. But there were other folks at the site who reported seeing it at the same time we did, but saw made 5 observations, 5 sort of on-off situations as it approached. They saw it along the same course that we did.
Right. And another interesting thing is the UAP detector actually activated about the second time we saw the flash. So it was maybe 300 feet away from us, and the 1.6 gigahertz sensor inside was triggered, and it's good to see that detector activated in a real life situation.
Due to yours. Yeah.
So yeah, it was incredible what we saw. It was a really small light, really bright white, very small. It came within 50, 60 feet of us. Was the last time we saw it, and it turned off or went out, and then we never saw it again. And we're standing around looking around. What the heck? Very strange.
You said it was a white light?
White, like a color temperature like 5,000 Kelvin. Very bright white.
Okay.
Almost like an arc. You do any welding, a stick welder, or a welder type of a bright white. It was hard to even see how big it was because it had the glare of the light, but it was small, like a golf ball size thing. This was my estimate. It was pretty small.
Did it seem to give off that light? Could you see the light going across the ground or in the trees or anything?
Yeah, I don't remember seeing, because it came right near the trees. I don't remember the trees lighting up. It was, it didn't light up the area, but it was bright. So yeah, it's an odd thing. I didn't really think of that before. You mentioned it. Didn't light up the area.
Okay.
But don't notice it. Remember it lighting up.
Ira, did you have another question? No? Okay. I'm sorry, Bill. Go ahead. Thank you.
Okay. All right, we can do another video. I'll just play it for you.
Yeah, so we had along with us in our kit, if you will, of detectors and various transmitters. We had a green laser that was used to sight one of the cameras, and we had that in the evening into the night, continuously shining on the mesa. It was about a kilometer away, and on one occasion, some of the other campers noticed a bright flash of light coming from the area of that where the laser was pointed.
So yeah, that's what I captured on the video camera that I didn't see until after the event. My brother and I actually didn't notice that when it happened. We were playing with the equipment, doing something. We heard a loud, loud noises from the other campers in the area. I thought they finally noticed that I had a laser aimed at the mesa. So I dismissed it. And then the next night they came over and said, "Did you see that flash, that thing around your laser yesterday?" I go, "No." And they described what they saw, and so I looked back at the video footage and saw this. So I didn't actually see it, but it was odd that this lights kind of looked like it was investigating the laser beam. If you saw it buzzing around, it didn't have its own beam or anything associated. It was just a light. Very strange.
Hmm.
Any questions on that one?
Was that one white as well?
Yeah, it was a light.
White.
It was, again, I didn't see it. This is
Okay.
black and white footage because it's in night mode. The people that described it as a flash. So this happened, and you saw it. It was played real time. It was only like there for a second or so. They didn't share the color of it with us. They just said it was, this flashing thing going on over by the laser.
Okay.
Yeah.
Thank you.
Okay. Then this one, I know you've all heard this before. I was skeptical myself. One of the other people that I've worked with is Chuck Bukowski. He's the famous guy in the field. When I was talking to him, he also described these battery drain problems. He has one of my detectors, and we talked about being able to detect that. So that's on my list for next generation detectors to monitor battery voltage. If I see a dip, to activate the sensor. In any case, while we were there, we had all kinds of battery issues. I assume there's some engineers out in the field, out in the audience here, and I'm pretty baffled from an engineering standpoint how batteries can just drain all by themselves. Where does that energy go? What's happening to the chemistry in the battery? I can't explain it, but we observed it. So I have a video here that my brother recaptures some of the things we saw, and some of it was incredible.
Yeah, we had battery problems when we were there. One of the most notable and definitely the most frustrating was the fact that one of the two batteries that supplies DC power to the camper went dead. Unfortunately for us, it also happened to be the battery that supplied power to the starter motor on the generator. So we were really dead in the water there for a while. We carried with us two portable battery car jumpers, and neither of those would work for us. They were both discharged. Coincidentally, I guess coincidentally in quotes, one of a nearby camper had problems with their car battery, and we noticed them trying to start their car with a portable power supply battery jumper. When we noticed that they were a little bit frustrated with trying to get their car started, we went down to help them, and then we asked them if we could borrow their battery supply, power supply, so we could eventually jump start our generator. In addition to the battery problems we lost at least two, if not three, power supplies plugs into the AC to charge up our cell phone batteries in our battery packs. A couple of those got really, really hot and would not function. Ultimately, they failed.
So yeah, there was a lot of battery problems. Can't explain it. Those battery packs I showed in the video, those are permanently damaged. I've yet to open them up to see troubleshoot inside, but they're dead. Same with some of those USB chargers. They permanently failed. Can't explain it. Any questions on that stuff? Okay. Doing good on time. Yeah, a few more minutes. So what's next? I've started working on another design. At the top here is the piece of board layout for the ET302W, the current design. And this new design I'm working on has additional sensors. Down on the left, there's an electric field sensor. Over here, there's a gyro sensor, 3-axis gyro. Down here, 10 gigahertz EMF sensor, a gamma ray sensor, and underneath the PC board, a infrasonic microphone, MEMS-based microphone to detect infrasonic sounds. So that's my plan. I probably won't get that device into the general public, just due to the cost of developing it and commercialize it. It's probably too high. But if there's interest and there's some professionals out there, I'm sure I'll make more than one of them. And as I have question marks down here, if anyone has ideas for additional sensor technologies, love to hear them. More the better. Collecting the sensor data, in my mind, if I have an event, say the 1.6 gigahertz sensor goes off, but I don't have infrasonic in it, or I don't have gamma ray, that's also useful data. It's good to know what these UAPs are not generating, what energies or what fields are not being affected by these crafts, is useful information. Okay, that's all I have today. If there's any final questions.
I have a suggestion. You may want to consider a neutron sensor on that.
Neutron sensor. I jotted down this neutron stream earlier, so yeah, that's on my list. Thanks.
Okay.
I'll look into that. I'll put a star next to it. Thank you. Anyone else?
The other thing is, if you've got an electrostatic sensor on there, you may want to also approach people who are ghost hunters, since the electrostatic plays key into those types of events.
Mm-hmm. Yeah, it's interesting you mentioned that, because I've noticed a lot of the ghost hunters will use EMF sensors too, which this detector's somewhat capable of doing. It's but narrow band, and there's also Bigfoot people, and some people say they're all connected. They're all related. Bigfoot's coming down from the heavens also. Who knows?
Yeah.
And maybe the UFO detector could be useful if that goes off and people see UFOs and Bigfoots around the same time. Maybe there's some correlation there. Who knows?
I have a friend who's a ghost hunter out of southern Minnesota, and they've noticed that UAPs will set off their equipment.
Yeah, it's interesting. And a lot of people investigating consciousness and how all this might be all connected. Sure.
Yeah, I was part of the Gateway experience, so I know about remote viewing and that type of stuff.
Oh, okay. Awesome.
Okay, does anybody else have any more questions? Does anybody else want to be in for the drawing for the UAP detector? If so, then please send me a chat message with your email address. I've got a few so far, and I think I kind of figured out how we're going to do this. But like I said, Bill and I will take care of that after the meeting, and we'll let whoever know. One. Anybody else? We got lots of time today. Okay, I had a question for you. Okay, if you don't have your UAP detector hooked up to the Wi-Fi, so in other words, it's not really going to your phone, does it still maintain its history? Is there any type of hard drive or what have you, storage on the detector itself?
No, there's no storage. It only would have that 20-hour window where, like, if you weren't home, you could come home and notice that the LED's flashing.
Okay.
So no local storage. I'm trying to fit that into that next generation detector. I'm getting a little tight on board space. You saw it's almost fully round.
Yep.
So it might be a challenge to get in. Maybe I'll need a little dongle cord that plugs in. It will have that serial connection on there that I showed earlier in the video. So you could access the raw data from the sensors. So that same USB connector could be used to store data on a little SD card.
Okay. So you don't have it built in, but it is possible to have it, if I was to hook up a USB port, or you have the USB port to it, a landline or whatever, if I was to hook up a USB thumb drive to it, it would store that data on there, and not unless I ask for it.
Yeah, not on the current design. It doesn't support that. I can modify, like I have for some other folks, modify units to add the serial port connection in the raw to access that raw data. It's not too difficult to do. But the SD card would also require some software changes to push the data onto the memory card, which currently doesn't exist.
Right on. Sorry, I got another one for the drawing, so
Cool.
writing that down.
Yep, and then I didn't really mention it, but of course the device is available on Amazon for anyone that would like to purchase one.
Yep.
And right now there's a 15% off deal that's available on Amazon to anybody.
Right on.
The list price is $295, and so they're selling for $250 right now.
All right, there we go. Excellent. I think it'd be well worth it for sure for the enthusiast and professional alike. So, I mean, this information we get off of this is could be quite valuable, especially for those people who think they may be experiencers or something. You know, you could set up something like this in your house, and if something was to happen in your house while you're asleep, you know,
Yeah.
you find out the next day. So it'd be a good time to have that thing actually hooked up to the Wi-Fi to see when things happen. So,
Yeah, and so it can, as I mentioned, this device, because it works with the phone app that's part of a home automation suite. So even on Amazon, you can buy Wi-Fi light switches, Wi-Fi dimmer switches, chime devices, you know, home automation type devices, and you can configure through the app that when the UAP detector activates, it can turn a light on or a camera or what have you, all in the same app. And those devices are relatively cheap, like $15 for a wall switch. So I actually have it turn lights on in my house when something goes off. And a chime, I have a chime that's remote too.
thank you very much, Bill. Really